What's up everybody, the Network Berg here. Hope you've been doing well. In this video we'll be going over the BFD. Sorry for laughing, but the name reminds me of a weapon in a game called Doom, and I suppose it does the same thing as in that game. It's really powerful protocol. So before we jump into the video, I just want to remind you guys to subscribe to the channel, like and share the videos. It does help grow the channel and I appreciate it immensely. Anyways, let's get into it. Alright, so let's talk about BFD, or the Bidirectional Forwarding Detection Protocol. So in a nutshell, it's a protocol that's going to be running between two devices on a link. So this link has to be connecting between these devices. It can be a wireless link, it can be Ethernet, it can be fiber, it can be whatever. But it has to be between two routers, because both of the routers will be running the BFD protocol, and this protocol will effectively be doing these, you can almost think of it as mini ping tests in quick succession to see if the link is actually up or down. Now what makes the protocol very interesting is when you mix it with your routing protocol like BGP or OSPF, the BFD protocol will tell your routing protocol, hey, this link is down, so ignore any routes that you're receiving from it. Don't even try and send out over it. This is not good. Trust me, you don't want to do this. And that's really the main point I want to make here, and I want to show you the errors most people get, because we typically run BGP and a lot of people just leave it on the defaults. So you'll get like a reconvergence time of 180 seconds, which is 3 minutes, because that is the whole time that your BGP is configured on. I just want to log on to this PE1 quickly and show you. So let's go into our routing, BGP. So if I go into one of my peers, so let's say my peer to router 2, which is this peer. If I open this up, I can see my whole time is 180 seconds. Sorry, I accidentally closed the window there. So let's just open that up again. But while that's opening up, you could probably lower the whole timer, but it still doesn't solve the issue. I mean, it'll still take the amount of time that you define here before your routing protocol even begins to question, are the routes still valid? And I'm going to show you a good example of this. So let's quickly check on this router, IP route print received from, where received from equals peer to R2. So this route that I'm learning from R2, if I jump onto this router 2 and I disable my interface that's connecting to PE1, so if I go interface disable, wait, let's just first see which interface it is. Ether 1 is 0, so interface disable 0. I'm going to drop the network, and if I go back onto Winbox of PE1 and I print the route, I'm still learning that route. If I go into my BGP peers, the peer is still seen as up. It's still thinking the peer is alive. So it will still be trying to send routes back to router 2, or it will tell the rest of the network, hey, to get to router 2, you can come to me, and it won't work because router 2 is effectively down and we are advertising it's still up. So in a better world, router 2 might have had another link to another router and we would have still been able to get there through that path. But for a majority of the network, it wouldn't work because we'd still be learning the old routes, the old updates that tells us to get there, go to PE1, and that link's not really up. So how do we fix this? We fix it with BFD. All right, so as I said, BFD, it takes two to tango, so to speak. So we need to first just re-enable this interface. And then what we're going to do is on PE1, by default, there is a BFD, let's say, protocol already configured that you can use out of the box. So if you go to routing, you'll see there's a BFD. And this you can already put on all interfaces, and it's already got its own intervals and the min RX time and multiplier. So these values are actually quite simple to explain. Interface all, this just means you can apply this BFD protocol to all of your interfaces. If you just want to put it on a specific interface, you can do it here. Your interval, that is the amount of time that it sends out these packets to verify if the link is up. So that is 1/5 of a second. That is 200 milliseconds. So you could lower that as well, but I mean, that's actually quite a good latency as well. If you want to think about it, if you had a wireless link or some satellite link that exceeded that type of interval, then maybe you wanted to push that up a little bit higher so that you don't run into issues where BFD thinks the link is down, but it is actually up. It's just having high latency. Okay, so that is what the interval means. That is what the min-rx also basically means. So interval is just in how many seconds it's going to send, and the min-rx is what the response that it's looking for. If it exceeds this response, then it's going to say, okay, this is not a good packet. And the multiplier is if it reaches this multiplier. So if 5 of the pings is over 200 milliseconds, then BFD is going to think this link is down, and it's going to tell your routing protocol the link is not good. You can think of this as being down. So you can tweak these values. We can make it 10. So then basically, if for 2 seconds the link is down, then BFD will kick in. But let's leave that on 5. So let's say basically if the link is down for longer than a second, BFD is going to kick in. As I said, you can create your own BFD by just clicking on the plus, and then you can tune your stuff here. But if you want to work with the default sensor, that's fine as well. And then what we're going to do is we're going to go into our routing, we're going to go into our BGP, we're going to go into our peer. So in this case, it's the peer to R2. And we are going to find use BFD. Dun, 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 dun. So we just tick that and we apply. Awesome. Now I'm going to do the same on router 2. And I might just do that through the command line quickly. So routing BGP peer print, routing BGP peer set use BFD yes. And let's quickly check. BFD should be running. It's actually running already. So how we can check if BFD is connected is you could go into your router again. We can go to the routing and the BFD. And if you look at your neighbors, there are your BFD neighbors. So it will tell you what protocols is running. Is it multi-hop? Is it up? And what's happening. So that's how many packets we're sending and receiving. And BFD, it's actually very low overhead, so you don't need to worry too much about putting on the protocol. Now, I want us to redo that test where we disable interface 0. And let's see what happens with that peer state. So keep a close eye on it, because remember, it was still ticking like on and on. It would have gone on for 3 minutes. Okay, so let's disable. And there we go. The peer's down, just like that. It's magic. And the setup, since it's so nice and it's so straightforward, it works the same on OSPF as well. So if you just go to your routing and you go into your OSPF, you might go into your instance. Actually, we don't do this on the instance, we do this on the interface itself. So this might be Ether 5. I can just copy this because this was a dynamically learned interface, but I'll leave it as is. But then we can just tick on the use BFD. But remember, if you run it on one side, you need to run it on the other side as well, else you're going to have a pretty bad time. So that wraps up the video for BFD. I hope it's been informative. Again, I'd like to recommend that you subscribe to the channel, and I thank you so much for watching. See ya.